Hi, welcome to Social Research Insights, and this is the third part of my video series on outlier analysis in LibreOffice Calc installed in Ubuntu 14.04. And in my previous videos I have explained you as how to simulate the dataset, and after that compute the confidence intervals for at 1 standard deviations, 2 standard deviations and 3 standard deviations. You can see the calculations in the spreadsheet. And after that I also explained as how to plot the graph at different confidence intervals, and I explained how to enumerate the outliers with the help of the confidence intervals, I mean the upper limit and lower limits, and also explained how to plot those limits in the graph, and later I explained as how to identify the outliers with the help of an if statement with combined which we use combined with another function called AND, and this procedure will result how many outliers that we can just simply count the number of outliers at 1 standard deviations and 2 standard deviations. And in this video, so we finished the first 3 steps. Step number 1, simulation of the dataset, and step number 2, calculation of the confidence intervals, 3, plotting the graph, and 4, calculation of the outliers. And this video I am going to show you the rest of the 2 steps, that is how to do the step number 1, simulation of the dataset, 2, computation of confidence intervals, 3, plotting the graph, and 4, identification of the outliers. And the final step, the step number 5, I am going to describe as how to take the decision whether we have to delete the outliers or keep the data as it is for our statistical analysis. So the process is very simple. We are going to compute the t-test for the mean differences. What I am going to do, I just copy the existing data into the separate column, and I delete all the outliers that I found through these calculations, and I recompute the average, and I perform the t-test to find the difference between these two averages, so that if the differences are significant, then we will keep the data without outliers. If the difference is not significant, then we'll continue our analysis with the actual data set. So that is the simple step that I'm going to do. First let me copy the existing data, actual data, into some other column in a separate column, and now let me identify the outliers. Here let me see, we are going to do this at 1 standard deviations. I mean, we are going to perform the t-test at 1 standard deviations. So this is an outlier. So let me highlight these points that are identified as outliers through our calculations, and let me delete them, and I'll go for a fresh calculation for the average. That's all. So this is the new average, and this is the old average. And if you see our average inflated after deleting the, so this is the actual average or mean. Let me put it very short. So the actual mean is, this is our actual mean, and the changed mean is going to be this. This is the changed mean. And now we are going to perform the t-test for the mean difference. So let me explain the method as how to perform the t-test to find out the mean difference. For mean difference, the procedure is very simple. The only difference from the conventional t-test to the test for the mean difference is the way we compute the standard error. For example, if this is the t-statistic, and the t-statistics is going to be x1 bar minus x2 bar minus d, which means the difference between the means, by standard error. So this standard error usually we compute for conventional t-test. We compute the standard error with a simple procedure that the standard deviation of the sample divided by square root of n. But here, for the mean difference, we have a different procedure to compute the standard error. That is, the standard error is going to be the pooled variance for the two samples, which means s1 square divided by n1 plus s2 square divided by n2. So this is the procedure to compute the standard error. So once we compute the standard error, we just have to substitute that value in the formula. We already have the actual mean and the changed mean, and here the d is going to be 0, because we are completely in agreement with the null hypothesis that the x1 bar minus x2 bar is actually 0. So the alternative hypothesis is that the d is not equal to 0. So this is actually two-tailed test. And so since we have no disagreement with the null hypothesis, actually the study hypothesis, alternative hypothesis. Anyway, I'm not going into the too much detail into the hypothesis formulation in this video. Perhaps I will explain that concept in a separate video. So here our d is going to be 0. So we are actually testing the hypothesis in this way. So my formula eventually will reduce to t is equal to x1 bar minus x2 bar divided by standard error. So this is the, because minus 0, so it doesn't matter, it's irrelevant for time being. So what I need to do, I first have to compute the standard error. So is equal to square root of s1 square. See here we I'm sorry, I think we have to compute the variance first, because we have the variance for the first variance, which means variance for the sample, and so we have the two way. This is the variance for the sample 2, and this is variance for the sample 1. So now we have square root of the variance, first variance, our variance for the sample 1, divided by count first sample, I mean this number of sample size for the first sample, plus the second variance divided by count the sample size for the second sample. So this is so this is the way of finding variance. Now degrees of freedom is going to be the minimum of n minus 1 count, I mean the sample size, n means sample size, n minus 1 or whichever is minimum, count the second sample minus 1. So this is the minimum, so whichever is the minimum. So I think we did a mistake in oh my god, minimum of count in minus 1. What happened here? Why I'm getting this in minus 1 comma minus 1. Will I get it? Yes, 8. So this is 8. 1 2 3 4 5 6 7 8 9. How come? Oh, okay, 9 minus 1, 8. So we got the degrees of freedom, and as well as so there is nothing the ununderstandable logic behind this calculation. The degrees of freedom is going to be whichever minimum out of sample size 1 minus 1 or sample size of for the second sample minus 1. So whichever is the minimum, that is going to be the degrees of freedom. Actually there is a different procedure. There is also another procedure to compute the degrees of freedom through this pooled variance, but this is the simple way that we can. I just wanted to keep my video cast short so that I'm not going for I'm just going for a simple way of computing procedure to compute the degrees of freedom. So now we are going for the t statistic. This is t calculated. T calculated. Is equal to x1 bar. X1 bar, I think we have here itself. X1 bar minus x2 bar divided by standard error. So that's going to be the t statistic. Thank God we got plus value. So now t critical at 5% significance level, critical at 8 degrees of freedom, is going to be t inverse 0.05 comma degrees of freedom. That is going to be t critical. So here the t calculated value, t statistic is less than the t critical value, so we are accepting the null hypothesis that the actual difference is 0, though we have some certain difference between the two means, but in the population we are not going to see such a difference, because this is only this difference is only out of the sampling error, so we don't have objection to continue our analysis on the actual data. That is, anyway, let me cross check my decision with the help of the p-value. So which means it helps us to know the probability of committing by choosing this decision, probability of error by choosing the decision, which means alpha. T distribution, calculate t value, degrees of freedom 8 comma mode 1. I don't know, sometimes it works without 1 and sometimes degrees t distribution, degrees of, is it minus value? Yes, absolute. Yes, so the p-value is 0.27, which is greater than 0.05. So at 5% significance level we don't have any objection to accept the null hypothesis. In other words, we don't have enough evidence through the sample data in support of alternative hypothesis. So anyway, by all means we are accepting the null hypothesis that the difference is actually not significant, so the outliers that we have, whatever we have perceived from the analysis, is not going to be poisonous for our analysis. I mean, they're not going to create any disturbance for our analysis, so we don't have any problem to use the actual data for the statistical analysis. Okay, this is the way we can perform outlier analysis in LibreOffice Calc installed in Ubuntu 14.04. Thank you.